Everybody? So if you notice it very carefully, if this is the car, if I have taken, now if I want to see the displacement in this car, I need to apply the force exactly parallel to the surface. This is the surface and I have to apply the parallel to the surface. Then in this case, work done is equals to force into displacement. This is what is the formula to calculate the amount of work done when we are applying parallel to the surface. The force is applied parallel to the surface. Are you clear, everybody? Now, if any kind of body, if the force is applied perpendicularly to the surface, all of you remember, force is applied perpendicularly, then displacement is what? Displacement is equals to 0 meters. Then totally, what about the work done? All of you. Work done is equals to, force is there, but displacement is 0. So which is equals to what? So what do you answer? What is the answer? Work done. Work done is applying perpendicularly to the surface. So work done is always remains what?
0.
Remains 0 because no displacement if the force is applied perpendicularly to the any surface. Remember, if this is the surface, if the force is acting perpendicularly, so what is the angle between them? Surface and the force, applied force. What is the angle, Hari? Perpendicular. This is the surface, and this is the applied direction of force. So what is the angle between them? Mitakshri? 90 degrees.
90 degrees.
So remember, if any kind of surface, I am applying the force with 90 degrees perpendicularly, so then the work done is equals to 0 joules. That is what you have to remember. Now, if I apply the force parallel to the surface, what is the formula, everybody? What is the formula? All of you.
Work done is equal to force into
Work done is equals to force into displacement. Now, if you notice it, in mathematics, you all people knows the triangle. Do you all knows the triangle? How many of you know the triangle? Yes, please. I want the response from you all. Have you studied about the triangle? Now, triangle, how many parts will be there? Tell me, everybody. Yes, please. 3 parts will be there. Correct or not? So the bottom part, what we used to call, Hari? What we used to say? Base we used to say. Is it right or wrong? Clear? All of you? Now, if I draw a perpendicular line, what we used to call that one? Height of the triangle, or we will say perpendicular line. Now, if I apply the force exactly perpendicularly to the surface, then what will happen? Is there any displacement in the body? Just now I told you, perpendicular. The force is applied perpendicularly to the surface. Is there any displacement? Any displacement in the body?
No, sir.
No, sir.
We can say work is 0. Now, if you want to see the displacement in the body, 2 ways we have to apply the force. One is parallel to the surface or with some obliquely. That is what you have to remember. So if I am applying the force some obliquely, in the case of boy who is pulling the toy car in with some angle, so then you can see that displacement will be taking place. So this is only ways to say with some angle. If I am applying the force, then you can see like a triangle, the base of the triangle, perpendicular part of the triangle, and this part we used to call something. Anyone can tell?
Hypotenuse.
We used to call this one is called as hypotenuse. So if you want to see the displacement in the body, we must apply the force either parallel to the surface or with some obliquely, and that angle should be varies from where to where? Between the theta, from where to where? Between 0 degrees to how many degrees?
90
degrees. Understanding? So then only the work is set to be done. So if you have taken the graph also, so always you have to remember, all of you, in the case of boy, the boy who is pulling the toy car, you have checked it. So he is applying the force parallel to the surface or perpendicularly to the surface or with some obliquely. Verify it, everybody. How he is applying the force here? All of you.
With some obliquely.
Yes, he is applying the force with some obliquely. So this obliquely he can apply in any direction in the sense of, you can see the force applied by him, that boy. If suppose he is very small boy or very large like me, suppose I am very tall. So you can notice it. I will apply the force in this direction. Yes or no, Hari? Obliquely. That boy is applying the force here. And some other boy can apply the force here. And some other boy can apply the force here. So whatever it is. So here angle will be 0 because parallel. Here angle will be, for example, 30. Here angle will be 60. Here angle will be 70. Now if I apply the force exactly like this, perpendicular, 90 degrees, no change. Now tell me, in all these cases, applied force will be same or different? Different angle, different force will be applied, or same force will be applied. Everybody? Mitakshri? Harish? Is it work done is same in every case? I am applying the force in 0 degrees. I am applying the force in 30 degrees. I am applying the force in 60 degrees. I am applying the force in 70 degrees. And I am applying the force in 80 degrees. Now tell me, in which, is it work done is same in every case or different? That is what answer from you I want it.
Different, sir.
Different, because the applied force is different, because in different angle I am applying, so that I cannot apply the same amount of force in every angle. Surely the amount of applied force will varies, and displacement also varies based upon the angle between the applied force and the surface. All of you remember, this is the surface and this is the angle between the applied force and the surface. So based upon the angle between the applied force, you can see here direction of force and this is direction of motion. So this is what the angle we will say. So this depend upon this angle, the amount of work done will be varies. So that is what you have to remember it. So at this case, what is the formula which we have to use to identify how much amount of work done we have been make when we are applying the force obliquely? Please remember that. Work done by a constant force acting obliquely. Please keep the heading. Work done by a constant force. Work done by a constant force acting obliquely means, what do you mean by obliquely? At an angle with whom? At an angle with the horizontal surface. That is what? With the horizontal surface. So that is what you have to remember it. Okay. Now, so what is the formula? Check it, observe very carefully. All of you, I am saying you, when we are applying force in a particular angle, then if you check it, the displacement of the body, I am imagining the car here. All of you remember the displacement of the body in which direction, guys? Same direction, parallel to the horizontal plane. Yes or no? Mitakshri? Yes, please. Please respond. And applied force is this direction. The force is applied in this direction, and this is the direction of motion. All of you remember? This is the direction of motion. Direction of motion, and this is the direction of applied force. Direction of applied force. So, and this is, what is this called as? Harish? Akilan? What is this called as? This is only called as what? Angle. Angle between the two. Who is the two? Horizontal and as well as surface and as well as applied force. Okay. Now, in this case, the formula for calculating the work done, W is equals to, all of you should remember, work done W is equals to, understanding, F into S into cos theta. So cos theta is a trigonometric function. So when the direction of motion is like this, we'll represent F cos theta. That is what, when we are applying the force in the obliquely, the force is equals to F cos theta, because applied force in which angle is cos theta will represent, and the direction of motion, that is what displacement is S. So that is the formula. So work done is equals to F cos theta S or Fs cos theta, your choice. Cos theta. That is what you have to remember it. Now, I will give you some values also. That values alone, they will ask you for your level. You all can learn the formula, learn and by heart that values also. So, what is the formula when we are applying the force obliquely? Everybody, formula, say it, everyone. Fs, Fs what? Fs cos theta. Is it okay, everybody? Please respond. All of you. Clear, Mitakshri?
Yes, sir.
Yeah. Now, I will give you the values for you people. Based upon that, we can solve the numericals also. Only few angles is very important. So that what is the angle and what is that value also I will say. So angle theta and what is the value? Cos theta. So if I have taken angle 0 degrees, 0 degrees means what? Parallel to the surface like this, understanding, angle is 0, then the value is 1, cos theta is 1, means cos 0 is 1. Next, if angle is 30 degrees, remember the cos 30 value is root 3 by 2. Okay, next, if angle is 45 degrees, the value is 1 by root 2. Okay, next, angle is 60 degrees, the value is 1 by 2. And if the angle is 90, can you tell me what is the value guessing? Angle is 90 degrees, what is the value will come? Cos 0, everything will be what? Force is everything, work done will be what? 0, because the cos 90 is 0. Next, if you want, you can take cos 180. Cos 180 means minus 1. That is you have to remember. Okay, means in the sense of, sir, what is this case? Can you explain? Means I will explain. Listen, if I am applying the force in this direction, but the displacement will be in this direction, then in this case, the angle between the surface and the force is how much, guys? How much, Harish? How much, Ra? I am applying the force. Suppose, see, this is the body. I am applying the force in this direction, but the displacement will happen in this direction. Understanding, opposite, minus case. The displacement is opposite to the direction of force. So in this case, what is the angle between the surface and the object? Everybody, force, applied force is 180 degrees.
Sir.
So in this case, the force will also will come negative. Negative indicating the direction of force is opposite to the direction of displacement. So these are the values which you need. Even in exam, they will ask you also for your level till 10th, they will ask you only these values: 0, 30, 45, 60 and 90. So please learn. Sin 0, sorry, cos 0 is 0, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, and sin 9, sorry, cos 90 is 0. Is it okay, Mitakshri? Yes?
Yes, sir.
Now, one more thing I am saying you, Harish, when this is horizontal component, understand, everybody, for your purpose I am saying you, very few of you can understand and you can remember, when the body is moving horizontal component, understand, Mitakshri, then work done is equals to formula, work done is equals to Fs cos theta. Is it okay, Harish? When a body is moving horizontal, that is you have to remember, horizontal component. Suppose If the body is moving like this direction, vertically, understand, Hari? If I'm applying the force, then the body is displacing like this. Then in this case, understand, Mitakshri? Vertical component. If the force is applied and the body is displacing, then in this case, the work done is equals to, you remember, Fs sine theta. Okay, everyone? Understand,
Yes, sir.
Hari? Fs sine theta. When? Vertical component. Clear? Mitakshri? Abhinami?
Yes, sir.
Fs sine theta. When? When the force is applied and displacement is towards to what? Towards to going away from the surface. Then in that case it will be happening. So please remember that. Okay, ma? Yes, Harish? Now,
Yes, sir.
yeah. So that is, please all of you remember. One is vertical component. Mr. Noor, understand or not? Akilan?
Yes, sir.
That is. So if it is
Yes.
horizontal component, what is the formula? Angle, obliquely. Fs, Fs
Cos
cos
theta.
theta. If it is vertical, then what is the formula? Fs
Sin theta.
sin theta. So please remember that. So that is what I want to just say. So if this is the force, then this is the angle theta. If it is the horizontal like this, then F cos theta is the formula. If it is the vertical, then what is the formula? Everybody, F sin theta. Okay. So please remember. Okay, Mitakshri, Abhirami.
Yes, sir.
So that is what you have to remember. Now, if F sin theta you don't have at all, anything, nothing will come till up to 11th class. 11th class only will get it, this Fs, everything. Mr. Nimesh, understand, Nimesh? Akilan? That is. Now, if it comes to that, he'll be having a lot of examples in Rechan book also. You can see all of you. So there they have been solved with the help of this formula only. So that examples both you try, so that we can write the formula. You can see F is equals to F cos theta into S. Now, this is the example which they have given. All of you can check it. So the angle between them, what is the angle between the direction of force and as well as displacement? Check it, everybody. How much is the angle they have given? All of you. 60 degrees. Understanding? And applied force is how much, ma? Check it, everyone. Applied force is how much?
5
Applied
newtons.
force, 5 newtons. And what is the displacement, Harish? Displacement is
10 meters.
newtons. So now, without seeing, you can tell me the formula. What is the formula? Fs, sorry, work done is equals to F into S into cos 60 degrees. So F is equals to 5 into S is equals to 10 into cos 60. Cos 60, how much am I? Check it the value and tell me. Just now I told. 2 ones are 2 fives are. So 5 fives are how much are they?
25.
25 Newton, 25 joules, not newtons, 25 joules. Work done is equals to 25 joules. Because cos 60, how much? Check it. Just now I told you correct. Cos 60, how much?
1 by 2, sir.
1 by 2. So what is the answer? Check it, everybody. How much?
25 joules.
25 joules. Are you getting the answer, Mitakshri? Now, if for example, cos 90, if it is perpendicularly applied, tell me, now person is carrying the load on his head. Now, how the force is exerting? Exactly on his head. How it is exerting? Check it. What is the angle here? Hari? Akilan?
90 degrees.
90 degrees. Then what is the work done by him? If I am carrying a load on my head, what is the work done by him? Work done by me? Yes, please.
0, sir.
Zero. Understanding, everybody? So that is you have to remember. For example, if I am taking a circular thing, so for example, Earth is moving around a sun or any kind of body, gravitation chapter, a boy is rotating a stone in a particular path. Now tell me at every point, applied force and the direction of motion. What is the angle between them? Direction of motion and applied force. Everybody. Yes, please. Whatever the point you take, applied force and direction of motion. What is the angle? Everybody. Yes, Mitakshri,
90, sir.
tangent. If you draw a tangent to the circle, what is the angle between them from the center? Any point. You might be remember gravitation chapter. If I draw a tangent to a circle, what is the angle, Harish? Tangent
90, sir.
90 degrees at any point. So if I draw tangent here also, what is the angle between them? 90 degrees. So if a body is traveling in a circular path, what is the work done by it? Anybody? What is the work done by it? I want the answer from you. What is the work done by it? Work done by it is equals to what?
0.
0, because applied force and the direction of motion at every point is 90 degrees. So cos 90 is equals to 0. So we can say work done when the force act at right angles to the direction of motion. So that is why you can see here they mention the work done on a body moving in a circular path is also 0, because when a body moves in a circular path, the centripetal force, do you remember in the gravitation chapter we are getting the centripetal force? Yes or no? All of you? Yes, centripetal force. So along the radius of the circle and the right angle to the motion of the body. So the body at every point you can see, the body will be ready to move at particular direction if the force is stopped to apply. So from the center at every point, the what is the angle between them? Everybody, what is the angle between them? 90 degrees. So always the applied force is you can take perpendicularly to the direction of motion in circular path. That is why the work done on a body moving in a circular path is also example for 0 work done. Or a person is carrying a heavy load on his head. What is happening here? Tell me. Angle between them, applied force and the you can see that displacement is 0 here. Cos 90 is 0, so that overall work is what? Overall work done by him is what? 0 only. Understanding? So a person who is carrying the load horizontal, like you can see, becomes 0, so that the man carrying a suitcase horizontally may be doing the doing the work against the forces like friction and air resistance, but total work done W is equals to 0 joules only, because applied force and as well as that is, you can see the angle carrying is 90 degrees, so that it will be 0. Cos 90 is 0, so that the man who is carrying the suitcase on his head, no displacement, applied force and the motion is 90 degrees, so work done is 0. Clear, everybody? Yes, please. All of you. So that is, so till here please learn. From here we will discuss tomorrow's class. I will explain you with the example and drawing the diagram, everything, so that you will understand all the cases when the work is done. 0 work done, positive work done, negative work done, everything will study in the tomorrow's class. So with this I will stop today's class. We'll continue here from tomorrow. Thank you everybody. We'll meet tomorrow's class.